Hello, you amazing humans. We're going to get into these notes on theoretical probability. Now, theoretical probability answers pretty much the question, in theory, what should happen? Right? And of course, I just covered the spot where you're supposed to put your date and the unit number, so that way we can keep our stuff organized. But we're just asking in theory. Like, this is the situation, this is the event, right? Because we have the probability of the event, and we're going to go through several different events. Events can be rolling a die, or tossing a coin, or spinning a spinner. Those are our events. Those are our situations. And we are just going to do the total number of favorable, which is basically just a fancy word for what? Like, what are we looking for? What are the wanted outcomes? Then we're going to put that over the total amount of possible outcomes. You know, for example, if we're tossing a coin, then if I'm looking for heads, then my favorable would be 1, right? And my total amount of outcomes would be 2, because it's one side of heads over 2 sides total. That's all we're doing. It's that simple. So we're going to, through each situation, we're going to find the total number of outcomes. We're going to find the total number of favorable outcomes. Basically, what are we looking for? Then we're going to put the favorable over the possible, so over the total. Then we're going to reduce or simplify our fraction. And then lastly, if the question asks us, we'll convert it to a decimal, because there are some questions that it'll be like a griddable on the test where you have to, type in the value, which will be in decimal form. So we have to know how to convert to decimals if we need to. All right, let's start with this first question. So what is the theoretical probability of spinning a section with stripes? Well, the first thing I'm gonna do is label my favorable. I'm looking for stripes. How many stripes are there? Well, there's 1. 1 section with stripes. How many sections are there total? Well, by basic counting, I see that there are 8 total. My last step is to put, well, not my last step. My next step is to put the favorable over the total. And then to reduce, but I can't reduce. I am going to convert it to a decimal just to show you guys that all probability is expressing a situation and in the likelihood of percents. Like, basically, what is a percent? And you know that percents are always between 0 and 1. 100 being 1 and 0 being 0. Like 50% is 0.5, right? All percents are between 0 and 1. So 1/8 is 0.125, which is also 12.5%. Now, that's kind of going above and beyond. You guys will not be required to convert to a decimal and a percent for every single question. However, that's essentially what we're doing here. We are trying to find the fraction form of the probability that we can then convert to a percent if needed. Okay, try that exact same logic with this spinner question. The spinner shown has 8 congruent sections. All right, beauties, if you got 3/8, that's your answer. You did not have to then go and do 0.375 and 37.5%. However, I like to show you guys so that way you know the whole picture and what we're doing. All right, I'm gonna give or try my hand at another example so that way you guys can try your hand at it. I'm gonna do Mrs. Mitchell's coin purse, and then I'll have you guys try the bag that contains the tiles. So Miss Mitchell's coin purse has 20 coins. They just gave me the total. I'm gonna write that down. I have 6 pennies, 5 quarters, 2 dimes, and the remainder are nickels. What is the theoretical probability, in decimal form, of randomly selecting a nickel from the purse? So my favorable are the amount of nickels. I need to figure that out because they don't tell me. So I'm going to add together all my coins that I do know to figure out how many nickels there are. 6 plus 5 is 11, plus 2 is 13. So 13 plus nickels should give me a total of 20 coins altogether, which means that there are 7 nickels, right? Because 7 plus 13 equals 20. So my favorable is 7 out of 20. And I need to do this in decimal form. So I'm gonna do 7 out of 20. Now, there are two options here. For me to convert this, I can just do 7 divided by 20. Put a decimal and 3 zeros. All right, so 20 can go into 7 0 times, so 20 can go into 70 3 times. And 20 can go into 100 5 times. The other way to do this, instead of doing long division, doing numerator divided by denominator, you can use scales. Let's see. I kind of don't know if I want to show you guys. Basically out of 100, and then we scale it. Why aren't I writing? There we go. Times 5. Times 5. 7 times 5 is 35. 35 hundredths is the same thing as 0.35, which is 35 hundredths. So in this case, I could have used either strategy to get to my answer of the theoretical probability of pulling a nickel out of the coin purse is 35% or 7/20. Okay, gorgeous humans. Try your hand at the bag of tiles. Okay, amazing humans. I hope you were able to get at least down to 1/2, which hopefully you realize that you just have that memorized as 0.5 as a decimal. But if you don't, you could always divide 1 divided by 2, put a decimal and 3 zeros. 2 can go into 1 0 times, but 2 can go into 10 5 times. You get the same answer, 0.5. Done and done. Okay, we have one more set of questions to go through because I try to, look at the STAR test and figure out what the types of questions they're going to ask us, so that way you guys are fully prepared on how to answer them. I'm actually going to try Rachel's. I'm going to show you how to do Rachel's because it's slightly more complicated than just the classroom. So let's go through this problem. Rachel is setting up tables for a party. 4. I'm going to circle that and put the number 4. The tables are covered with red tablecloths. 8 of the tables are covered with white tablecloths. Guests will be randomly seated at the tables when they arrive. Each table, keyword, each table can seat 8 guests. Oh, I'm going to have to do some extra math here. What is the probability that the first guest to arrive will be seated at a table with red tablecloth? So I'm looking, that's my favorable, red. Okay, the reason there's extra math here is because I know how many tables and I know how many seats per table. I need to find the total amount of seats. And then I need to figure out the total amount of seats at the red tablecloths. So if there are 4 red tables and 8 seats each, then how many seats are at the red tablecloth tables, right? We just do basic multiplication, 4 times 8. So there are 32 favorable seats. That's what we're looking for. We're looking for the seats with the red tablecloth. But then how many total? There's 8 tables with the white and 8 seats each, which means that there's 64. So I need to add together, that's 64, that's 32. I need to put together 32 and 64, right, to find the total amount of seats we got. We got 96. Total 96. Oh, man, these are kind of big numbers. So theoretically, the theoretical probability is 32 out of 64, which clearly we're not leaving it like this because we have to reduce it. I could actually see that they're both reducible. Reducible, is that a word? Simplified by 8 can go into both of them. So I'm just going to reduce them both by 8. Sorry, guys. I'm a math teacher, not an English teacher. So 32 divided by 8 is 4. 64 divided by 8 is 8. And see, these are numbers that I recognize, 4 and 8. I know that 4 is half of 8. So this reduces down to 1/2. My theoretical probability of the next guest that's going to arrive is 50% chance to be seated at a table with red tablecloths. Done. That's a lot more math than I'm going to ask you guys to do. So give your hand at the last problem. You can do this. You're smart. All right, you beautiful humans. I hope you were able to get to the answer of 4/15. That is in theory, the probability of the next guest that's going to arrive, the next student that will arrive in the classroom will be seated at the front row. It's got a 4 out of 15 chance. Okay. If you're thinking, wow, Miss Palmer, that was like really simple. That's because you understand it, and that's a really exciting thing. If you don't, though, please, please, please ask your teacher for help. That is literally our job, and we love to do it.